Welcome to the New American Home 2023 webinar series. This is the second of two webinars that we've hosted for the New American Home 2023. Today, we're focusing on the home's performance and providing you with 10 tips to achieve a high-performance home. Thank you for joining us, and we have some great insights to share with you today. My name is Rich Binsacca. I'm the editorial director of ProBuilder Media, the official media partner of NAHB and the New American Home program. I will be your moderator for this session. Joining me is Drew Smith, the COO of Two Trails, a high-performance building consultancy with offices in Parrish, Florida, and Las Vegas that serves as the energy consultant and verifier for the New American Home and has for several years. Most of what you'll hear and see today comes from Drew and his team's work with the design build team for the home and their extensive modeling and testing process. You might also hear the voice of our producer, Ray Harwood, namely when we ask you, the audience, a few questions along the way. For the next 40 minutes or so, we'll discuss the New American Home's performance in terms of energy use, water use, and indoor air quality, as well as how the team was able to achieve some very impressive results in that regard. You are encouraged to ask questions as we go, so please use the chat button at the bottom of your screen. I'll be checking them as we go, and I may stop the discussion to answer a question or actually have Drew answer a question in a moment. If not, we'll try to get through all of them or as much as we can in the Q&A portion at the end of the program. This webinar also is being recorded, and we'll be posting it to probuilder.com/webinars within a couple of days if you want to view it again or share it with a colleague on social media. This year, the New American Home celebrates 39 years of delivering great design, innovative ideas, and the latest product applications. Built annually in the host city of the International Builder Show, the program started with a 1,500 square foot home in Houston in 1984, and has since grown in footage and significance. For comparison to that first home, this year's exhibition home is a spacious 8,200 square feet. The home is produced by NAHB's leading suppliers council in partnership with ProBuilder Media and its publisher, SGC Horizon. The program also has a website with additional information about the project, sponsors and their products, and videos featuring the project team and others involved in the program. Please go to tnah.com to check it out after the webinar. ProBuilder also will feature the finished home in our March-April issue coming out in a couple of weeks. And we highlighted the products in the home from the program sponsors in our January-February 2023 issue. There's also a slideshow of the finished home on the probuilder.com homepage. So you can check that out. Some photos like this one of the office that aren't in the article and aren't going to be on this webinar. So a few more of the photos of the home. And then coming to our website soon, an article by Drew about the home's performance and how the team achieved it. Essentially, this webinar in print form with some additional images as well. Okay, before we dive into the 10 tips, I want to give a little context about how the home performs and what it achieved. So for those of you familiar with a HERS index, this home with a solar array achieved a -15 score, so net zero and beyond. Without solar, it scored a 50, which means it is 50% more energy efficient than code minimum. As far as water savings, indoor and outdoor combined, 50% below baseline. Air tightness, 2.98 air changes per hour at 50, and Drew will go through that term and kind of what it means and where 2.98 ACH compares in terms of air tightness generally in the homes that he and his team see. It achieved the Emerald status at the National Green Building Standard or of the National Green Building Standard, and also EPA's Energy Star for Homes certification. In addition to those two green building programs, the home also earned EPA Indoor Air Plus certification, and many of its water-using products are also EPA WaterSense certified, and several products are Energy Star rated. Okay, so here's our first audience survey. So this is quick yes or no. I use one or more national, state, or local green building programs to certify my new home. So this will pop up on your screen, and please take it, and we'll reveal the results in just a half a minute or so.
Looks like the answers are settling down now. Ending the poll and sharing the results. Looks like we've got 29 for yes and 51 for no.
Okay. Okay, great. So 36% yes, 64% no. Great. I appreciate that that feedback. Okay. So let's get into the 10 tips. And these are tips that Drew and I have talked about, and that actually Drew, I know you use pretty comprehensively through the work that you do, especially in residential. The first one is collaboration. And to me, and I think Drew, you agree, it's just as tactical and important as window flashing or insulation or air sealing. But tell us kind of why this is such a critical part of achieving high performance homes, and how you actually achieve collaboration, and who with.
Thank you, Rich. Collaboration really starts with the design team. So when pen goes to paper, we want to be involved as the energy consultants on the project. So we're working with the architect, the mechanical engineer, and the structural engineer to make sure that throughout the entire process, when a decision is made, we can have input as to whether that decision is going to have a negative or positive effect on the high performance of the home. So we're looking at, we start with early on with energy modeling to be able to, what that does is we're plugging the house into a software program with all the windows, the doors, the ceiling heights, the window sizes, the direction of the home. And we can then at that point, as the plan evolves and the home evolves and the ceiling heights change and overhangs change, we keep changing the model to see how that really plays into the entire energy effect of the home. And working with the team, they're constantly bouncing ideas back and forth and making suggestions for new products and so forth. That's all a part of the collaboration. We have either on-site meetings or having meetings via internet, or we're having individual meetings with team members to put the home together to make sure that every decision that's made and every product that's selected works to the best of its ability. And these type of homes, a little different than the average normal home, because a lot of the products here are donated, and all the suppliers that want to be in the home want their products in there, and we have to make sure that we can showcase those. So we have to work with the hand we're dealt with, so to speak. We have to make sure that all those parts and pieces are incorporated to the best of their ability, and they shine, as well as making the home as high performance as possible.
Right, right. Yeah, it is a bit of a unique situation with these idea homes, demonstration homes, that there is that component of it, and an obligation, like you said, to kind of incorporate and showcase some products. But hopefully the manufacturers are on board as well and understand the energy and other resource efficiencies that we want to achieve with this house and this program. So hopefully it's not too big of a hurdle or a wrinkle, but I know that it's part of it.
No,
Okay,
it's
so
actually it's
yeah.
kind of a plus, really, Rich, because we end up learning from some of these suppliers. We end up using products we haven't heard of before, or we're using new product on the market. Where we get to make sure, and we become a sounding board for them. And so it's a collaboration. That collaboration goes with the vendors and suppliers as well. And sometimes they find out that their product needs to be incorporated with another part of their product to make it actually function better. Right. So in all, it's the team effort of this really puts not only a great high performing house in the ground, but it also helps these suppliers build a better widget, so to speak.
Right. Okay. Well, let's go on to tip 2, which is systems approach. And so you've got the design build team on board. They're collaborating with you. They're collaborating with each other. You're collaborating with suppliers as well. But how kind of define a systems approach in terms of how you look at it and how you present it and kind of how it manifests, through the process.
The important thing is we're trying to look at is start with the envelope of the home, and we want to make sure that all products and all phases of the home are performing in concert with each other, that we're not putting in one product that then hurts another product in its performance or showcasing it to its highest ability. So that system approach is it's like building a very intricate steam engine, so to speak. We're building this home, but if you don't put enough overhang over a certain, for instance, west facing or south facing glass, and you have too much heat into that room, things of that nature, you're gonna have to ramp up the air conditioning in that area. And so that's where that systems approach comes in, is okay, how much insulation do we want to put in? How much is enough? How do we want to approach the insulation? How do we approach the air conditioning systems, and what type of system should we put into the home? Right on down to, the cabinetry, and is it going to off gas, and the colors of the cabinetry, are they going to reflect light to where we can minimize putting lights on in the kitchen, for instance, during the day?
Okay. Yeah. Interesting. Okay, great. Well, that's terrific, Drew. That's great. Okay. So at what point do you bring in the trades? And I'm guessing, because most builders, whether they're custom shops or production operations, we know that most of them use trade partners to actually build their homes. So at what point do you bring those companies in, especially those, well, I would imagine almost all of them are affected by what you do, but the major ones for sure. And how do you how do you get them on board, especially when we've got such a tight labor market?
Well, it's important to get them involved as early as possible in the project. Typically, once a set of the home has been designed and we're into construction drawings, it's time to start meeting with the major trades, explain what we're trying to achieve, and they then understand as part of the process that they're going to be showcased in the home as well. So they get some marketing out of being part of the extra work, so to speak, that it takes to build a showcase home like this, because there's definitely more time involved. There's overtime involved, and getting them excited about the project and what's actually going to happen, and that there's thousands of people that are going to see this home and see their workmanship, and they can use it on their resume. They can use it on their website. There's pictures available for them. They can take all their pictures during their phase of their work so that they can document that they've been part of the process. And they want to be involved because they want to be part of something that's brand new, and they learn as well as everyone else. They're learning how their product can make a difference, and possibly a different way of doing something because of a home like this. Even with a limited trade market, there's still skill building involved, and the subcontractors and trades want to be able to hone their skills, so to speak.
Right. Okay, excellent. Thanks. Okay, let's get into some of the best practices, both in the design studio and in the field, starting with passive solar design. Drew, I pilfered some of these terms from your upcoming article and your report, so I apologize for that in advance. But let's dive in to define them and kind of what they look like in application, and then how all of them impact the home's energy load, the use of artificial lighting, and indoor air quality and comfort and health. So let's talk a little bit about leveraging the sun's natural light and heat, and maybe start us out with kind of, I think this is how you define passive solar, but maybe kind of explain the term a little bit.
Well, with passive solar, is you really want to use as much of the sun's power and natural lighting as possible without having to turn electric lights on in the home, especially during the day. So leveraging the sun's natural light and heat is extremely important, and that can be done in a number of different ways, such as strategically placed fenestrations. Where do you place windows? Can you put clear story windows in, like this picture example shows, huge sliding glass doors with also lighting above. That passive sun light coming in through the clear story windows gives you all of that natural light during the day, reflecting off of, as you notice, very light colored walls, ceilings, floors. So during the day, this particular home, almost 90% of the home, you can function during the day without having any lights on. And that's very important. And that has to do with the orientation as well. In most cases, you're limited on orientation. You're bound to the property lines. The home can only be put in a certain direction. But how you orient your views, your windows, and how you handle shading, how you handle overhangs can dramatically affect in a positive way how much passive solar you can bring into the home. So we look at all of that and try to maximize put windows where you can put them, higher windows for privacy, but still you're bringing in natural light. I mean, and you can have windows in some cases inside the home that aren't an exterior window. It's a window between two rooms, but it's bringing light into an interior room.
Right. Excellent.
And you can see that. And I mean, the floor plan, this first floor plan kind of illustrates, we're bound to that site. And so the architect had to design the home where the rooms, the public spaces, were going to have not only the best views, but also the best amount of light. And so it takes that light study, it takes shading studies that the architect goes throughout the process, as well as, you've got to be able to project where those windows are in the bedrooms so that you're not invading privacy from the houses next door when you have a tight site that you're working with.
Yeah, go ahead. Sorry. This is a really tight site. I mean, he maximized it in the setbacks that he had, but he's got neighbors on both sides that are pretty close. And if you look at this plan and you see kind of where the windows are on the two side elevations, there's not a lot of exposure there in terms of privacy. It's really pretty tight. And it also is, elevations that are kind of facing the sun's orientation in a kind of a fortunate way, if you will, as well.
Yeah, we were lucky with this one because the south side, we didn't have to put a whole lot of windows on it, and that's your worst exposure for heat, and so, but it's also a great exposure for daylighting. But the problem is you've got a house right next door that's totally blocking any views. So the windows there again were oriented higher where they were, so that you didn't have invasion of privacy, but you could steal some light during the day.
Right. And then, in the front of the house, which, is not where the view is, it's to the street, obviously. You've got, and we'll see a picture of this in a minute, you've got the garages, you've got a long covered entry, kind of an open air courtyard that's there, but really not exposed to that elevation. And then you've got an office that basically, the only window in that is really not in the office. It's actually the hallway that leads to the office. So really kind of minimizing that. And then on the back side, on the rear side, where you have the view, you've got your more entertainment spaces, your public spaces, and we'll talk about kind of how you protect those. And you mentioned it a little bit. And then upstairs, we've basically got bedrooms, closets, laundry room. Really not a lot, and certainly on those vulnerable elevations, really nothing going on except an open air kind of porch at the back. So really, and this is maybe talk about kind of how this kind of approach, and you mentioned the Claire stories, but really this is protecting this house from a lot of heat gain, right?
Oh, most definitely. The sides of the house where it's really critical, such as the front here, which is south and southeast exposure, has either the black area that's sheeted with a black metallic finish, that's a garage. So it's a non-conditioned space, and we don't worry as much about that space. But you'll notice the other wall, which has the stone on it, which is white, it's reflective, allows a lot of the heat to bounce back off. And the clear story windows, again, are pulling that light in during the day. And there's light shafts, if you notice, next to the left of that white brick wall, those are lighting that hallway up to bring light in to that whole transportation space, or on the first and second floors.
Right. And then on the back, completely different. We've got a very exposed elevation here, and that's to take advantage of the views, but also designed to kind of minimize whatever heat gain you might get from that exposure.
Exactly. Yeah. It pulls a lot of light in, but it's shaded enough to where we don't have a huge heat gain, which we'll talk about in a little bit.
Right. And just for context, this is the lower level game room. And I'm going to split back a little bit so you can see that on the lower left, that's the game room, and then above it is the primary bedroom. But there's a corner wall of glass here. This is facing basically west southwest, or west northwest. I'm sorry. So basically, what are kind of the elements here in terms of the spec for the doors here, the glass, as well as some of the other things, the overhangs, and you mentioned kind of there's the clerestory window there that kind of peeks out as well.
That's the important thing, is you start with very efficient glass. So we have solar heat gain coefficients in the low 20s on all of this glass. So you're bouncing most of that heat and light, and it's also insulated glass. So we're doing maximize what we can do on the glass itself. But then you take it to the next step, and you notice the overhangs. Pretty large overhang on the rear of the house on those sliding glass doors. But there's also retracting shades that come down that are sun controlled, or can be sun controlled, so that as the sun starts to set to the west, the shades go down in conjunction with that sunset to be able to shade those sliding glass doors from the hot afternoon sun as it starts to set. So you've got that multiple layer protection, so to speak, throughout the entire day, all the way until sun sets, to be able to keep that house running at maximum efficiency, as high performing as possible, with minimal use on the air conditioning system.
Right. Okay. And then here's the upper level, same kind of thing, deep overhang over the porch there, the insulated glass, the shading system, which is concealed. And then, like I said, if it's censored to the sun or the heat, it then drops down. And of course you can manually override that to get out to the porch or the balcony and see the view. But yeah, when that sun hits, especially in Vegas, you want to make sure that you've got some protection there. Okay, let's move on to the thermal shell, which obviously is a critical element to lowering the overall energy load, reducing thermal transfer, among other things. So let's talk about that a little bit. And again, tell me what you mean by starting from the ground up, because this is the term that you use when you describe the thermal shell. But let's walk through that a little bit.
Well, starting from the ground up really refers to from the first piece of insulation, which can be in many cases. We didn't particularly do it in this home, but the slab itself and the floor area can be insulated. And so in some cases, if you're in a climate where you have a very long cold climate, you'll want to insulate the floors as well as the walls. So we look at, is it beneficial to insulate the slab itself under the slab? Is it beneficial to insulate the edge of the slab? And then we work from there all the way through the wall system. And what we look at on the wall system, typically on these type of homes, to get a real high performing home, is to do multiple layers of insulation. So this particular home has a foam insulation on the exterior. It has, and it's 2x6 walls. We spray open cell foam between the studs, but not a full distance, full depth. And it's twofold. The reason for that is we're now adding a product on the inside of that, which is called 5-foil, which adds another R5 to the R value. But by minimizing the amount of foam in the walls, you're saving product. It doesn't have to be shaved. So we're not putting shavings into the landfill. So we're pretty much cutting your spray foam bill in half and achieving the same R value for a lot less cost.
Right. And that reflective insulation is it just a sheet and it gets an R5 just from that little thin reflective sheet?
Exactly.
Wow.
Yeah, it's the airspace that's really gaining it. That's why you're only installing half depth on the spray foam, is because you want that air cavity between the hi-fi and the spray foam to allow for that gap to that's where your R value is really captured. Okay. And so we've been using that type of system for a while now, and we've found that it works very well in pretty much every climate. It's been tried, true, and tested now in the Vegas market as well as the Florida market, and we really like the layered effect. And you can go further. I mean, the further north you go, the more or thicker the insulation on the exterior may want to be.
Right. Okay, and then let's talk about air sealing, because I know this is a big deal, and there's product out there that does a pretty remarkable job in a pretty innovative way to kind of seal up the at least the inside and thermal shell. So tell us about kind of what you used, and I know you referred to it kind of in a clever way, so I want to kind of let that
we've been using for the past few years, we've been using a product called Aero Barrier. I like to call it fix a flat for the house, because what it is after insulation is all done, but right before drywall, the company will come in and set up these tripod sprayers that will then inject a mist of foam particles into the air while they're pressurizing the house with the same blower door that we use to do our testing. They use that same type of blower door system. They turn it around. They're actually blowing air into the house because they're trying to force that airborne foam into every little crack and crevice throughout the house. And so it's finding all of the spots that the insulation guys missed. It's finding caulking areas that got missed. It's missing, areas possibly around penetrations or around where the plumber put pipes through the walls. And it's any little gap up to a ½ inch, it will start sticking to it and keep sticking to it. And we can have them keep running this system until we can achieve the possible lowest and tightest envelope we can at that particular time and in space. Right. So at that pre-drywall stage, we want that house as airtight as possible. And so they'll keep running this foam until they've literally sealed up all the cracks and crevices. Okay. And then they stop, and then we take over from there. And that product that we found has really been able to help us achieve that a very low ACH rating.
Right. And I would imagine that, any little gap that you can seal, it all multiplies, right? So it might be just a little gap around a penetration or something, but if you can seal that up and seal all of them up, you're really helping out your thermal performance because you're not allowing air, moist air to come in and get into the cavity or get into the house, or even, certainly the other way of kind of, allowing conditioned air out into the world. So it really kind of helps you in terms of energy load and then also system efficiency and all of that. And we have a question here. I want to make sure we get to it because it relates to the gap that you talked about between the 5-foil and the spray foam in the wall cavities. And it's a question about can air gaps like that create a thermal loop? And maybe you can address that a little bit.
Not particularly. They won't really create a thermal loop because each cavity each cavity between the studs is going to have its own cavity, so to speak, because but they don't all connect.
Right.
I think I'm answering that question.
Okay. Yeah. So basically you're saying it's self-contained. So a thermal loop would be more of an open area rather than a contained,
right,
4-inch stud space.
Once you put that 5-foil on, it's more like it's a large. I could look at the exterior walls as almost like a large bubble wrap.
Right.
If you can picture bubble wrap, it's kind of like each one of those stud cavities is its own little bubble.
Okay. Okay, great. Thank you. Okay, second survey we've got here. And yes, this is just a yes or no or I don't know. So three answers really quick. I deliver homes with less than 3.0 air changes per hour. And Drew, while we're waiting, kind of how do you it's the blower door test that tests for for air transfer, correct? Or air sealant or air tightness?
That's correct.
Okay. So it really is a question about whether these attendees or builders conduct a blower door test, because that's really the only way to do it.
Exactly. Yeah, that's an important test, even if it's not code required. It's still be important to know how leaky you're building your homes. We even do them on multifamily projects at the pre-drywall stage so that they can tighten up the envelope prior to drywall, and then they use that punch out technique throughout the entire project. If we do the first building, then they develop a punch list from that.
Okay. And where does 3 air changes per hour kind of compare to, let's say, code minimum or homes that you've seen that maybe are either existing homes or new homes where they haven't done a blower door, they haven't done some of the things that you've talked about? What's typical, or what's kind of code level air tightness? How does it compare to what we did here?
Code in most municipalities is 7 air changes or less.
Okay.
5, we see some municipalities at 5. This particular area, Henderson, Nevada, actually does have a 3.0 minimum.
Okay.
So we're definitely below that.
Okay.
But every municipality is a little bit different. But so yeah, we're just in comparison, we're typically about half of what most of the country is.
Okay, great. All right, results are in. Yes, 29%, 19% no, 53% then say they don't know what their air changes per hour is for the homes that they build, or the homes that I would imagine mostly builders here, so the homes that they build. So we got 53% that don't know, and I wonder, and we can talk about this, maybe down the road, but I wonder how much, if those codes are, 7 or 5 even, how much, what's the incentive then to really air seal, much less test for it. So that's interesting. Thank you for those who participated. Appreciate that. Okay, let's move on. We got to kind of get going because we've talked a lot about precursor stuff. Now we're kind of into the tactical stuff. So right sizing your HVAC system. Great thermal shell allows builders and trade partners to right size the heating, cooling equipment, usually downsizing it to reduce energy use, but also maintain equipment and maintenance costs for that equipment. So let's talk about that a little bit. So right sizing the equipment why don't we just go kind of, I'm going to have all these come up and have you kind of talk about, because this is really a systems approach. This isn't just kind of one thing or another. And I think all of the things that we're talking about are kind of, systems integration, not each individual component kind of acting in itself. So let's talk about the systems that were used in this house, Drew, and then we can at the end kind of talk about how the element of control can certainly maintain or even enhance the energy efficiency that you've achieved.
Sure. The air conditioning systems were all LG, and they were all the VRF cassette type systems. So not your standard mini splits, but these are actually built into the ceiling. That would be your standard wall mount mini split that you see in the picture. That's
Right.
not what we used. We used the systems that are actually built up into the trusses. So the nice part about these systems is it eliminates areas of hotspots or not being able to get to a certain area because the duct work won't fit. These systems are very small. They're compartmentalized. Typically, you're running one bedroom and one bathroom on a air handler unit, and it has its own thermostat. You can put up to typically 5 of those air handler units on one condensing unit outside. So it minimizes your footprint outside because we can put multiples on, but it also allows that homeowner the flexibility of controlling each one of these rooms independently. There could be someone in one room that wants heat on, and another room have cooling on, and that system will run simultaneously with each other. Duct design minimizes the ducts with these type of systems. Ducts are a lot smaller because they're very short runs. It works so much more efficiently. The efficiency rating on these and sometimes can be almost double. So you're used to hearing of a 14 SEER or 16 SEER unit. Some of these units are getting up into the 24, 26, 28 SEER. So they run much more efficiently. They run much more quiet. They are all variable speed. So they ramp up when the demand goes up, and they ramp back down. The ducting extremely tight because there is very minimal amount of ducting. So we're really lucky to have these type of systems, and I totally am a big advocate of using them whenever possible. We're finding more and more of these type of systems being used because we're doing a lot more contemporary type designs, which have flat roofs, very minimal truss space, and these type of units really help us get from one space to another without a lot of issue. And balancing the house and controlling that system is very simple. And then we can also integrate HRVs whenever we need to. We can HEPA filtration can be incorporated whenever it needs to be, and we can put those into the main public space units, which are a little larger. And the system really works in concert with each other very well, and bringing in fresh air as well.
Right. And that's a question that we actually had in the chat about how is outside air brought in. So you mentioned you got to that. There was a question too about where the return air duct goes, or how you manage return air. Is it in the ceiling? Is it, how do you look at that, and specifically putting in the ceiling? What's your opinion on that, or is it kind of circumstantial to the house?
It really depends on the house and the design, but typically the return goes in the ceiling. It's very similar. The system when they're installed look exactly like a standard standard air handler system that that most people are used to with regard to duct, your grills and so forth. In these particular homes, we do a lot of linear diffusers, but your linear diffusers can be both a supply and a return. In these homes, we typically put the supplies on the window or the hot wall of the house, with the return on the cool wall of the house, and so that we get that circulation of air throughout
Right.
the space.
Okay, excellent. Thank you. Okay, let's move on to indoor air quality. So you've built a really tight house, which means you need to ventilate it right, correct? So if you don't do that, you're going to risk some unhealthy indoor air and comfort. So it's obviously critical. Obviously, there's a program out there, the EPA's Indoor Air Plus program, that gives a lot of great guidance. And then you have to consider a lot of different systems that, again, are working in concert to meet or exceed, those standards. And ultimately, what you want is to deliver a comfortable and healthy indoor environment. So take us through, these steps. I'm just going to kind of drop them in here. But there's a number of things to pay attention to, including lighting, and we'll talk about that in a minute. But walk us through these kind of major components of achieving indoor air quality.
There's been a saying that we've been using for quite a few years now called "built tight, ventilated right." So it's really important. The tighter we're now being required to build these homes, that we do incorporate proper ventilation. And there are code requirements once you get below 3 air changes per hour of actually putting in ventilation. Up until that point, it's not required in most areas, but highly recommended. So you always want ventilation. You want the home to respirate, basically just like someone being on a respirator. You want it to breathe. We want outside fresh air to be pulling in throughout the house, throughout the day, but not bringing it in without conditioning it. That's important. It's very important that any air that's brought in from the outside gets filtered, gets dehumidified, and gets brought into the home properly, so that you're not bringing in unfiltered, stale air that is either too hot or too dry for the environment. So we always run it through either an HRV, an ERV, a HEPA filter, and then it goes typically through an air handler before it actually is delivered to the space. So no air goes directly into the living environment without going through some type of conditioning. Extremely important with indoor air quality, especially now after the pandemic, with as many people working from home. We've got that home needs to breathe throughout the day, but it has to breathe with clean, fresh air.
Right.
The other part of indoor air quality is lighting. It's extremely important to use the right color shading for lighting, use the right proper type of LED bulbs, so your space is comfortable and relaxing. Some people function better with 3000 K light bulb. Some folks like daylighting bulbs, which are more around the 5000 K brightness. So the lower the K, the dimmer or softer the light. The closer you get to 6000 K, the brighter and whiter that the lighting is. And that's a personal choice and also comfort to each individual.
Sure. Okay. And I want to add too, and this goes a little bit back to the energy efficiency part of the conversation, is that the entire house is 100% LED, both inside and out. I mean, you've got outdoor lighting is LED, all the indoor lighting is LED, which obviously has an energy saving component as well.
Correct.
Okay.
And occupancy sensor is extremely important whenever possible, to put them in as many spaces as possible, so that your lighting are going, they're turning off when you don't need them. Also, they can dim. You can have them adjustable so that you have different comfort zones throughout the home.
Right. In a home like this, I think especially, but even so, I mean, even if you're working from home, I mean, how often do you go into your bedroom during the day? You're in the kitchen, or you're in the living room, or an office, or you're not even there. That light, even if someone leaves it on, if you will, but if it's automated and it's dim and it's on a sensor, it's going to turn off. It's not sitting on all day. It'll sense only when someone enters the room, and it'll spark up then. Okay. Let's talk about indoor water efficiency, and just just for context, and we'll start indoors, is that, again, this home achieved a tremendous amount of water savings, 50% against baseline. So that's incredibly impressive with this kind of resource. So how did you accomplish those savings inside the house, Drew? What kind of things did you, and we're going to kind of just list them here and kind of have you talk through them, because some of them I think are a little less obvious than others.
Plumbing fixtures, Kohler donated all the plumbing fixtures for the home. So working with the builder's interior design team and Kohler, because of course they want to display their most current fixtures, but they're also, the positive is Kohler has gone to almost all low flow type fixtures anyway. We try to focus on all of the water closets. We try to focus on the kitchen faucets, focus on the lavatory faucets, and most of the showers in the home. We kind of have to work a little bit more strategically with the master shower, because everyone wants to see the full body wash type, full spray gamut in there, and that's what most people want now in their shower. So what we like to do is, how do we hit that water savings with every other room of the house? But for example, this picture showing the master shower, there's a lot of shower heads going on here. Not all of them work at the same time. So we put as many control valves in as possible, so we're not wasting water and having 5 heads run when you don't need them. Right. So it allows that homeowner the choice of how much water they want to run and use in their master shower. But we work on all the rest of them first, and then do the best possible job we can to minimize water flow in the master shower by using the control valves that go along with the system to just have 1 or 2 heads going at once, or if body sprays are going, the other heads are shut off, vice versa. With appliances, if they're a fixture that's using water, we're going to make sure that best as possible we're minimizing its water use. Pool pumps is a great example of efficiency. The new variable speed pool pumps that are Energy Star rated are extremely efficient. They run and do the job of a standard single phase pump, and typically less time and a lot less water use, because the longer the pumps are running, the more evaporation you're going to get. So we're looking at how effective can these pumps be in a shorter amount of time, because especially in Las Vegas market, water use is extremely critical, and running pool pumps for 8 hours a day is you can lose a huge amount of gallons of water based on the surface area of the pool, but also the features. Water features are a huge evaporation factor that we have to look at.
Right.
And then tankless water heaters, they're a phenomenal way of minimizing your hot water use, because it's basically almost like point of source. But we take that to the next level, at least on this particular home, or these show homes, is we put in the sensors to where it backfeeds back into the water heater, so that we're not circulating. Even with tankless, we are not circulating hot water. We're only pulling hot water into those rooms when it needs it. So when you're not in those rooms, or you're out for the day, those tankless water heaters aren't even running.
Oh, okay, gotcha. Okay, so give me an example. So I'm walking into the bathroom, or is that something I do manually to sense it, or is it automatic sensor and it says, okay, hey, there's somebody here, or they're going to engage. They might engage a faucet, so I want to make sure there's hot water available.
There's either motion sensor operated, or there's push button operated.
Okay.
So there are areas like the kitchen, you would want a push button. You wouldn't want it on a motion because
Yeah.
you're in and out of the kitchen all day, getting a Coke out of the fridge, whatever. You wouldn't want that to be running and causing it to pull hot water to the kitchen faucet when you're not there.
Right. Okay, great. And then in your experience, and you've been doing this long enough that you've gone through the kind of, low flow, low water use fixtures and fittings, specifically faucets, shower heads, water closets. How is the technology advanced to the point where it can be low flow, but still deliver, kind of performance that meets people's expectations?
That keeps getting better every day, Rich. We're finding that most of the manufacturers they've had to overcome that that negative stance there, or that's been out there, that low flow fixtures don't perform well. That's not the case, especially with low flow toilets. What we look for and what a builder should look for is the map rating of the toilet. The better the map rating, the more it will flush. And typically now is probably 80% of what's being manufactured has map ratings that are performing at where a 3.0 gallon toilet used to perform, but at a 1.8 flush rate now.
Right.
So that's the important thing, is you can get there. You just have to look at the specs. Right. They will perform. Same with shower heads. There's technologies that the manufacturers have come out with now to give you the feeling of a 2 gallon per minute shower head and only be delivering 1.5.
Right. Wow. Okay, great. Thank you. I want to make sure we address that, because I think that's a concern that builders have, and certainly want to get on the right side of, so that their homeowners experience, what they expect, and aren't, complaining about that. So I'm gonna go ahead.
One little tidbit: these don't have to cost any more money. The important thing to understand is in most cases, you can get water efficient fixtures at any big box store at pretty much no additional cost, unless you're getting to something with a high designer fashion.
Right.
But they can be bought now for the price of a high water use fixture.
Okay, that's great. That's a great point. That's a very important point. Okay, I'm just going to stop us here for a second. We've got 5 minutes left in the hour that we had scheduled for this webinar. We're going to stay on past the hour, most likely. We've got 2 more tips to go. We've got some Q&A that we might get to if we can. If anybody wants to stick around, we're going to do that. And then we've got some business to take care of toward the end of the webinar. I want to thank some folks that were part of sponsoring this. So I just want to let the audience know that we're going to keep going past the hour. You can stay with us. We hope you do. But we've got a couple more things to do, and we're just running a little short of time that we'd hope to get done by now. So I want to talk about outdoor water efficiency, because I know that this is also critical. That a lot of water, and you kind of alluded to this with the pool, but a lot of water is used for landscape irrigation, turf irrigation. So I want to talk about kind of how this house and any house really can kind of minimize that water use. So let's talk about kind of, these kind of components, and certainly you can add more to this, Drew, but this house seems to have all 3 of these things, and maybe you can kind of go quickly through kind of what this house is and what this house did, and how outdoor water efficiency can really be achieved.
Sure. The drought tolerant landscaping, extremely important, and that typically is landscaping that's native to the region. So you want to pick plants. We did here plants that are native to the Las Vegas area. So they're set up, and the plants are used to not having a lot of irrigation. And then when we do have to irrigate, just for the very dry seasons, we try to use drip irrigations. We use micro irrigation. So we're trying to minimize evaporation. So all of the water is being delivered directly to the plants on a one-on-one basis, typically underneath the rocks or mulch or what have you. as you can see here in this picture in the middle, that's a micro irrigation spray head. So it's being directed directly to that plant. And typically the irrigation is being run not in the middle of the day. It's being run either in the evening or in the morning hours, so that most of that water is being captured by the plants. We also try to minimize turf areas. Turf areas are definitely a water hog, so to speak. There's no other way about it. The turf needs water to grow, and even the drought tolerant type turfs we're finding are having a hard time surviving without water, or if they do survive, they're not green, and everyone wants green.
Yeah.
So we try to minimize turf whenever we can, or use artificial turf if someone needs that turf area.
And those artificial turfs, I mean, they're pretty great right now. I mean,
Yeah.
you drive, I mean, it used to be like a carpet, but now it looks like grass, and there's no mowing, there's no watering. I mean, it seems like a pretty good solution there.
I agree.
Yeah. Okay. All right. I want to jump back into energy, because this is, and we're going to end with this as the last tip, but renewable energy, obviously this house has that. It achieved a -15 HERS index with a rooftop solar array. So I think it's kind of the culmination of what we've been talking about, specifically with the energy related stuff. You know, if you lower your home's energy load to the point that this house did, you and your team and the builder team did, it means you can kind of, you know, right size your solar. You're not asking it to do more than it needs to. And then that obviously reduces its cost, it reduces its installation, and also, you know, increases its payback period, basically delivering only the energy that you need or you can afford. So maybe walk us through the specs here, and I have a question about how many panels are actually in this array, in a 20 kW array with these 400-watt panels.
The picture you're seeing, there's 50 panels in this particular home.
Okay.
And yes, you made a great point, Rich. I won't totally repeat it what you said, but that's important part of the integrated design in the collaboration up front, is how do we minimize the electric load and then cover the balance with solar. So as opposed to just throwing solar panels on the roof and trying to get to a zero energy home, we want to minimize that electrical demand up front and get that HERS index to a 50 or into the 40s, or where as low as we can go before we start sizing the solar, so
Right.
that you're only putting on the minimal amount of panels you need to get to zero energy.
Right. Okay. And then obviously there's some other factors too, with location and orientation, the
Exactly.
roof type and the roof finish, and the shading. And I don't know that this house doesn't have any real trees around it, so I don't think shading's really that big a deal.
No.
But it could happen with another roof or another building, obviously next door, if that's the case. But talk to me about kind of, you know, specifically the orientation of this. And if you remember back at the floor plan, these panels are basically facing south, which is what they should. And then, or ideally should. And then as far as the roof type and the roof finish, kind of how that helps or doesn't hinder any way the performance of the panels.
Well, there again, we go back to collaboration. We knew we were going to put solar on the home. So the design team, in their design aspects of the home, were already planning, how do we design this so that structurally we can put solar on it, how much solar we're going to need, so we have the space for the right amount of panels, that it is oriented correctly. And then the white roof is a pretty typical thing. The white
TPO
membrane,
roof. Yeah.
TPO roof, or is typical for what we see on a lot of product in the Las Vegas market. So that helps to reflect energy or heat back off the house, which really helps with the heating of the roof. Yes, we didn't have shading to deal with on this one, and typically we like to use our micro inverters for these systems. I recommend those above a regular inverter because they if one panel goes bad, the rest of them are still powering. So you're
Okay.
not bound to one inverter for the entire system. So that's kind of where we go with those. And then maintenance, every system's going to require maintenance on solar. So you got to be able to get to the roof. So don't put it somewhere where you don't have access to it once it's installed, because you know, at least once a year the panels should be washed off. They just build up dust and dirt over a period of time, that rain, water spots. So you want to clean them just like you clean windows.
Okay, that's great. I was going to ask you kind of what you do there, but obviously there's people that do it. And I would think in markets like Vegas, there's probably a good infrastructure of solar panel maintenance folks. But even if it's just the homeowner, you know, it seems like if you just treat it like a window, then you'll get them to the point where they're going to be, you know, maintained properly in terms of their cleanliness, in terms of their ability to kind of, you know, absorb that that energy from the sun.
Yeah, and you notice they're spaced so that you can walk between them, walk
Right.
around them to be able to service them.
Right. Awesome. Okay, great. And then the microinverters, just a quick question. So are those one-to-one on panels, or does a microinverter, you know, carry more
Tip
than one panel?
one panel. If you're
Okay.
doing microinverters, it's panel per panel.
Okay, great. Great. Okay, last audience survey for those of you that are still with us. And I'm curious about this. Again, 3 options here. Does my state or municipality require renewables, such as they're going toward, well, essentially going toward in California and other places? Discussing mandates for renewables, solar, wind, or encouraging renewables through some sort of voluntary program or some sort of utility incentive. So I'm just curious kind of where the audience is on this. And so we'll give you a few seconds and we'll reveal those results to you. And Drew, while we're waiting, there's a question that came up. I want to make sure that we get to it, since it's basically the LG system, and you know that what's the he wants more information about it. So I think it's just lg.com, I think, or you can search by maybe what was is there a system name for that, or something that can help that person search a little bit?
Well, yes, go to the LG website, and then you'll go to the either VRF or cassette type systems.
Right. Right.
On their HVAC, because they also carry standard split systems.
Gotcha. Okay, good. And then a question about artificial turfs, which can be recycled. You know, have you heard much about that? I know that's really not your bailiwick, but in terms of recycling those artificial turfs and the environmental impact of that.
Yes, some of the artificial turfs can be recycled because there's a large amount of plastics, and they're actually made out of most the turfs. Artificial turfs are made out of recycled plastic.
Gotcha.
So it starts that way, and yes, it can go through that cycle again.
Excellent. Okay, I think we've got the results here. Okay, so of those who are in the audience who responded to this, 16% said that their state or municipality requires renewables. 11% said that those authorities are discussing mandates, and 74%, which is really, this is actually pretty great, encourages renewables. So we're getting, you know, a lot of builders who are being encouraged through voluntary programs, incentive programs to put renewables in. And obviously, you can't put lipstick on a pig, right, Drew? So you got to make the house really energy efficient, lower that load, and really optimize those solar or renewable systems so that they do what they're supposed to do, and not more than they're supposed to do.
Exactly.
Okay. All right. Well, you know, since we're 6 minutes over, and let me look at the chat to see if there's any questions that we really just want to get through before we get off. And otherwise, we will answer them offline. So we've got all of these captured, folks. So I think what we're going to do is just kind of move through Q&A. We've answered a number of questions as we went, so I'm glad for that, and thank you for everyone who's contributed to the chat. I do want to recognize the team. This is both the Leading Suppliers Council team, the NHB team, and of course the Design Build team. Michael Gardner AIA and principal of Luxus Design Build and founder of Studio G Architecture. That's him on the far left. He's the mastermind behind the design and the construction of the house, and his team was terrific. And then also Ted Mahoney, who is the New American Home 2023 chairman and president of Windjammer Construction Corporation in Bridgewater, Massachusetts. So thanks to the entire team, and Drew, you and your team as well, for doing this house and putting it all together and making such a great project and a great performing project. Just a reminder that this webinar is being recorded, and it will be posted to our website, probuilder.com/webinars, within a few days. And there you can view it again or share it with a colleague or on social media. Again, Drew, thank you very much for joining us. Always great insight, always great to talk to you. Not just the information, but the tidbits that you throw in are terrific. So thanks again for joining us.
My pleasure. Thanks for having me.
Okay. I also want to thank our platinum sponsors for the New American Home 2023, Signature Kitchen Suite, LG Air Conditioning Technologies, LG for its laundry equipment specifically, and then also Simpson Strong Tie. We'll be back next year around this time to present the New American Home 2024, also in Las Vegas. Until then, have a great day, and thanks again for joining us.